Good evening, students. Welcome to EdCrest, and we are going to start today one of the geometry part of MYP 4 Maths, trigonometry. In trigonometry, we are going to do very basic stuffs, okay? And when I say very basic stuff, first we have to understand in trigonometry stands in which kind of question we are going to apply trigonometry, okay? So trigonometry can be applied to right angle triangle. What do I mean by saying right angle triangle? Any triangle having one angle as 90 degree is known as right angle triangle. Okay, it can have only one angle as 90 degree. Okay, because you know that interior angles, if you add all of them, it becomes 180 degree. So only one of them can have 90 degree. I'll always try to name a triangle. That is always a good habit of doing that. Okay, so we see that in any triangle there are three sides, AB, BC and AC, and these three triangles, these three lines or these three sides are known as, the first side is known as hypotenuse, the second is known as opposite, and the third is known as adjacent. Okay, now how to identify which side is hypotenuse, opposite or adjacent? Okay, for this, remember that you need to know which is a right angled angle, okay, in a triangle. Apart from that, you also need to know which angle you are referring to. Okay, what do you mean by angle? So you know that apart from B there are two angles, angle A and angle C. Okay, so angle is represented by theta and angle is represented by, it's not necessary to be represented by theta only, okay, but its unit will be degree. Okay, so it's represented by degree, theta degree, alpha degree, x degree, y degree, it can be anything. Okay, so theta is just a variable to demonstrate angle C. Okay, now for hypotenuse we need to understand whichever, we are talking about the sides here. Okay, so whichever angle is 90 degree, the side opposite to that is hypotenuse. It's always hypotenuse will be the same irrespective of this angle theta. Okay, wherever theta is there, right angle, you just have to see the right angled one. Right angle, if you find it out, the side opposite to that right angle will be the hypotenuse. Okay, side opposite to right angle. Okay, so here that is AC, the hypotenuse is AC. When I talk about opposite, I have to consider this angle. Okay, so if the angle is theta, then my opposite will be, for theta, you see that AB is the opposite side to theta. So here it will be AB. Okay, side opposite to the angle. Which angle? So the angle for which you are trying to find it out. And adjacent will automatically become the third side. Okay, because we know that there are only three sides. Okay, so in this way, the first part of any right angle triangle, the first part of trigonometry is very important to identify hypotenuse, opposite and adjacent. Once you are okay with it, then we can use the trigonometrical ratios formula and then we can solve the question. Okay, so quickly we will see few more examples and we'll try to identify if they are, which side is opposite, which side is hypotenuse and which side is adjacent. Okay, so suppose I draw a triangle like this. I'll try to name it ABC, and this side is 90 degree, which means it is right angle at A. So whenever you see this symbol, it means this is a right angle triangle, right angle at A. Quickly, the first question would be find the hypotenuse. Your immediate answer will be, sir, side opposite to 90 degree, which is BC. Second question is opposite. So for opposite, we need to know an angle. Suppose this is x degree. Okay, so for this x degree, my opposite will be AC and adjacent will become AB. Now this is for x degree. If this is for x degree, we are trying to say, but suppose this is y degree, and for y degree, I am trying to find out the same thing. My hypotenuse will still remain the same, which is BC. Okay, but my opposite is going to change now. My opposite for this y degree will be AB, and thus my adjacent for this will become AC, this side. So these things you have to take care of. There are a lot of examples, okay, which will be uploaded in the edcrest.com. So you can go and refer there. Right now, we are going to take one more example. PQR, and this is a right angle triangle, right angled at R, and this angle is y degree. For this y degree, my hypotenuse is always going to remain the same, opposite of 90 degree, which is PQ. My opposite is going to be the opposite of y, which is QR, and adjacent will be the third side, which is PR. In this way, in any triangle, you can find out opposite, adjacent, and hypotenuse. This is the first basic thing, okay? So this is known as how to label any right angle triangle, okay? So once you understood how to label a right angle triangle, life becomes easy for you, correct? Now we are going to see what are trigonometrical ratios. See, there are normally three trigonometrical ratios. What are they? Sine theta, cos theta, and tan theta. Now see, sine, cos, and tan are three trigonometrical ratios, but they are always accompanied by a degree variable. Okay, theta degree. Okay, theta I have already referred in the last part. Theta always refer to one of the angle, okay, which is in degree. Okay, now they have a formula for it. Okay, the formula for sine theta, now this stands for a right angle triangle. Okay, I'll show a right angle triangle here so that you can understand what I'm trying to say. ABC, where B is a right angle triangle. We know that theta, now theta can be here or here. So suppose I put theta here. Okay, theta is my A degree here. Okay, it is always in degree. Remember, if it is radian, you have to convert to degree for this whole study what we are doing right now. So sine theta formula is opposite upon hypotenuse. If you see here, what is my opposite? For this theta, my opposite is BC. And my hypotenuse will always be AC. Okay, because it is opposite to right angle triangle at B. Similarly, if you talk about cos theta formula is adjacent upon hypotenuse. Now we know that if this is opposite, this is hypotenuse, so this AB will become adjacent. So this will be AB upon AC. And third part, tan theta formula is opposite upon adjacent. Okay, so for tan theta, opposite is BC and adjacent is given as AB. So these are the three trigonometrical ratios. How do you remember this thing? Okay, will this be given in exams? Yes, the formula will be given in MYP 5 e-assessment examination. School exams that you have to go and ask your respective schools and teachers, they will be able to guide you there. Okay, but see, it's very easy to remember this. Okay, I'll give you a shortcut to remember this. Even school is going to teach you the same thing. So it's so ka toa. You just have to remember this three words, so ka toa. So means sine theta is equals to opposite upon hypotenuse, cos theta is equals to adjacent upon hypotenuse, and tan theta is equals to opposite upon adjacent. So if you are going to learn this, you are going to learn the basics of trigonometry. Okay, hope this makes sense. So ka toa. So it means that now we have the formula with us. I'm going to rewrite the formula here so that we can solve few questions. So sine theta is equals to opposite upon hypotenuse, cos theta is equals to adjacent upon hypotenuse, and tan theta is equals to opposite upon adjacent. Okay, so these are the three formulas. I am just writing it for reference. E-assessment, it will be given into your exams. Okay. Now take any example. Suppose in any example, in example, if I say that ABC is a right angle triangle, right angle at B. So what they can do, they can just give you one angle. Suppose they give that this angle is 30 degree and they can give you one side. They can give you any side. Okay. Suppose they give you this side as 4. And then they ask you that find all the remaining sides and the remaining angles. Okay. Find, this is 4 centimeter. Find AB, length of AB and AC. Angle, you can find it. Angle A will be what? The addition of all these three is 180 degree. So if this is 90, this is 30, this will become 60 degree. Okay, this is pretty simple. You must have learned all this in MYP 3. Now we'll go and try to find AB. Okay, now we have to understand, if we have to go and find AB, which formula we are going to use. Okay, because we have been given an adjacent and an angle and we have to find opposite. Correct? So we have to find opposite. Adjacent is given and theta is given. So for which theta, the formula stands for adjacent and opposite. Come here, hypotenuse, hypotenuse, this. So we are going to use tan theta because opposite and adjacent are given here and theta is given. So out of these three things, 2 are given, 1 is not given. So we can easily find this. Correct? Let's see. So tan of theta is equals to opposite upon adjacent. Correct? So tan 30 degree is equals to, for 30 degree opposite is AB and adjacent is BC. So BC is what? 4 centimeter. Correct? Now how to find tan 30 degree? So you will be provided with a calculator. Okay. In examination, basically there is a e-assessment, there is a button there. As you click, they will open a calculator. Okay. This will not be this calculator, it will be a simple calculator, but you can go and do it. Please remember, while you use a calculator, lot of people I have seen using wrong way in a calculator. Okay. So you have to be smart while using a calculator. Okay. So in a calculator, first go and check, this is a sine. Can you see SIN? So this is the trigonometrical ratio sine. Go and press this and press 90 first and see what is the answer. It should be 1. If it is 1, your calculator is in degree mode. Okay. See, this is a GTC calculator. So here you can see the degree mode here written as DEG. Okay. In the basic Casio calculator or the calculator which will be provided to into your school, you have to check if it is degree or not. The best way is to check sine 90 or cos 90. It should be 0. If it is satisfied, it means that it is in degree. Okay. Now you can go and check for tan. So you see tan is here, TAN. Just go and press this 30 degree, 30 and execute. You will see it's root 3 by 3. So root 3 by 3, I go and press this. I get the value 0.57735. After decimal point, I'll just try to keep 2 decimal points. Okay. So I'll write 0.577. So 0.58. Okay. So tan 30 degrees 0.58 is equals to AB by 4. Therefore, my AB is 0.58 into 4. So again, come here back. This is 0.58 and I'm going to multiply it by 4. Oh, there's something wrong here. So I think I have to go and write back again everything. 0.58 into 4. 2.32. So the length of AB is 2.32 centimeter. Okay. Why centimeter? Because BC is in centimeter. So all other units will be in centimeter. So now you have got AB. To get AC, there are 2 ways. First of all, use Pythagoras Theorem. From there you can get AC. But if you want to go and choose to do it by trigonometry, definitely you can. So when you go and see AC, your theta is given, your BC is given. And the best part is that your AC is now, AB is also given. So BC is what? Your adjacent is given. And you have to go and find your hypotenuse. Correct? So the best way to do this, hypotenuse and adjacent, is cos. So go and write cos 30 degree is equals to adjacent, which is 4, upon hypotenuse AC. Cos 30 degree, come back here, go to cos, I hope you guys can see this, cos 30, it's root 3 by 2. cos 30 degrees. So I have to go convert into decimal 0.866. Okay, so I'm going to write 0.87. Correct? 0.87 will be my cos 30 degree. 0.87 is equals to 4 upon AC. A lot of people do wrong here also. If you cross multiply, AC will go at this place and 0.87 is going to come below. So 4 upon 0.87, took my calculator, 4 divided by 0.87. This comes out to be 4.59, which is 4.6. So it is 4.6 centimeter. Okay. See, in this way, you can find with one angle and one side given, you can always find all the remaining sides of a triangle. Okay. So this way you can solve a lot of questions of trigonometry. The sheet will be uploaded there in edcrest.com. You can take it from there. Now the third part is how to find an angle if sides are given. Okay. How to find an angle. So you have to understand that in any trigonometrical function, you will be provided with two things. Minimum two things has to be there. Then only using trigonometrical ratio, you are going to find the remaining things. So suppose this is your right angle triangle. I'll name it as P, Q and R, right angle at Q. If it is right angle at Q and I have to find maybe angle, I have to find angle P and angle Q is already given. Okay, so I no need to find angle Q. Angle R I have to find it out. Okay, and suppose this side is given as 3 centimeter and this side is given as 4 centimeter. Okay, now two sides are given. Third side definitely you can find by Pythagoras. As and when required, you can find it out. No need of doing it here. We can do it here. Okay. Now if I want to find angle P, so I'll mark this angle P as X degree and R as Y degree. Now why do I mark this? Basically because it will be easy for me to understand that I have to now find X, and according to X I can take my opposite and adjacent. Okay. So to find angle P, what we are going to do is, first of all, we have to understand that if I want to find this, I have to use either sine, cos, sine x, cos x or tan x. If I use sine, sine is opposite upon hypotenuse, but my hypotenuse is not given. Neither x is given, neither hypotenuse. So I land into trouble. Cos, if I use, then cos x is equals to adjacent upon hypotenuse. Again, I cannot use it. So now it comes to tan, which is opposite upon adjacent. My opposite and adjacent both are given. So now I can find my x. Okay, it means that I'm going to use tan in this case. Okay, for every case, the trigonometrical ratio to be used will be different. So my formula will be tan x degree is equals to opposite, which is QR upon adjacent PQ. Tan of x degree is equals to QR is 4 centimeter. This is 3 centimeter. Okay, so which comes out to be 4 by 3. 4 divided by 3. 1.33. 1.33. This is tan x degree. Any unit for 1.33? No, it do not have any unit. Now understand how to find x. Okay. When you go and find x, you have to move this tan to that side. So normally understand tan is not, it is not tan into x. Tan x is a single term. So if you want to move, normally what happens if you do y into x, you can place y in the denominator. But here it is not possible. Why? Because tan x is a single term. So x becomes tan inverse of 1.33. So you are getting it how to write this x. This is very important point. Okay, just note it down. How to find tan inverse from calculator? Come here. You can see tan is here, correct? Okay, I'll try to delete this. Tan is here, and just above tan you see this tan inverse written in gray color. How to go with this? You press shift here and then tan. Tan inverse of 1.33. So I'll place 1.33. And your answer comes at 53.061. So I'm going to write 53.06 degree. So my x is 53.06 degree. This is the value of my x. Got it? Now I have to go and find y. How to find y? Simple. I know that for y, again I am going to use tan only because my opposite and adjacent both are given. So tan y degree is equals to PQ upon QR. Tan of y degree is equals to PQ is given as 3, QR is given as 4, which comes out to be 3 by 4 is 0.75, but still I am going to use my calculator. 0.75. So y is going to be tan inverse of 0.75. How to use tan inverse of 0.75? So again, you have to go there, shift, tan inverse of 0.75. It comes out to be 36.87 degree. So y is equals to 36.87 degree. Okay. So this is the way you go and find the angle x and angle y for this. So again, whenever you have to go for this kind of thing, you have to understand that your two sides have to be given. If your two sides are given, then only you can go and find the remaining angles. If third side, suppose if you have to go and find PR, so there are multiple ways to find PR. Because this is a right angle triangle, you can definitely go and use Pythagoras Theorem. And in Pythagoras Theorem, you can go and you can write PR square, which is the hypotenuse whole square, is equals to opposite whole square plus adjacent whole square. So PR square, PQ is 3, 3 whole square is 9, QR is 4, 4 whole square is 16. So PR is equals to root of 25, which comes out to be plus minus 5. But we know that distance PR cannot be negative, therefore it will be 5 centimeter. Hope this makes sense. How to find an angle. Okay, now let's go to the third part. In third part, suppose they are giving you the trigonometrical ratio. Suppose they give you that sine theta is equals to 6 by 10. And now they are asking you, go and find the remaining angles and sides. First thing you have to understand that sine theta is given as 6 by 10. So you have to first draw a right angle triangle. This is your 90 degree. Always try to name it XYZ this time. Okay. And place your theta. Your theta can be placed wherever you want. You can place your theta here. You can place your theta here. Okay. So mostly I am placing it here every time. This time I am going to place it here. Theta. You know that sine theta is opposite upon hypotenuse. It means that this is your opposite, which is 6. Opposite upon hypotenuse. Hypotenuse is opposite to the 90 degree, which is 10. So this is your 10. And now you see we again got a triangle with two sides. Now if they ask to find cos theta, what is the value of cos theta? What is the value of tan theta? You can again go and find it. How you can find it out? So first, these two sides are given. You can go find this side xy. How to find this xy? We can use Pythagoras Theorem of xz whole square, which is hypotenuse whole square, is equals to perpendicular whole square or opposite whole square plus adjacent whole square. So xz is equals to xz whole square is equals to xy is what? Xy is not given, so xy I am going to write as it is, plus yz is given as 6 square is 36, and xz is given as 10 whole square is 100. So 100 and 36 I'll bring it here, minus 36 is equals to xy whole square, which means xy is equals to 100 minus 36 is root of 64, which is plus minus 8. So the answer will come as 8. Okay. If this is centimeter, this will be centimeter. If this is meter, this will be meter. But plus it. Why plus it? Because length cannot be negative. Okay. So we get this xy as 8 units. The cos theta, if you see, is what? Adjacent upon hypotenuse. So it's 8 upon 10. You can definitely go and write this in a smallest ratio, 4 upon 5. When we talk about tan theta is opposite upon adjacent. So it's 6 by 8. So 3 by 4. So using trigonometry, one trigonometry ratio, you can find the other trigonometry ratio. If you want to find the angle, you can find the angle because two sides are given, and we have learned how to find an angle for this type of questions. Hope this makes sense. Okay, and this is the basic of trigonometry. Okay, now we are going to learn few things about sine, cos and tan. Okay, so I'll show you here. I'll try to make a table of sine. This is your theta. So sine theta, cos theta and tan theta. See, I recommend this part to be learned. Okay, this table to be learned, because if you learn this table, life will be very, very easy for you. So theta, I'm going to take 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Okay, we are only going to work from 0 degree till 90 degree. The value of sine 0 is 0. Sine 0 degree is 0. Sine 30 is 1 by 2. Sine 45 is 1 by root 2. Sine 60 is root 3 by 2 and sine 90 is 1. So you see, from 0 to 90 degrees, sine is getting increased from 0 to 90 degree. Okay. On the other hand, cos always works opposite to that of sine. Okay. So you see that sine 90 is 1, therefore cos 0 will be 1. Sine 60 degree is root 3 by 2, so cos 30 degree will be root of 3 by 2. Sine 45 and cos 45 meets at the same place, so the value of both of them becomes 1 by root 2. Sine 30 degree is half, therefore cos 60 degree will also be half. And sine 0 degree is 0, so cos 90 degree will be 0 degree. So sine and cos just reverse each other. Reverse in the case that it goes from top to bottom and it goes from bottom to top. It goes from bottom to top and cos goes from top to bottom. Correct. Okay. So just remember this one, because if you remember this one, life will be easy for you. Definitely you have the calculator, you can use it at any point of time, but I recommend this one to be used. Okay. Now tan theta, remember tan theta, the formula for tan theta is nothing but sine theta by cos theta. Just remember this, tan theta is equals to sine theta by cos theta, and your life will be easy. So if I talk about tan 0 degree will be sine 0 by cos 0. 0 by 1 will become 0. Tan 30 degree will become sine 30 by cos 30. If you divide both of these, 2 will get eliminated. It will become 1 by root 3. Tan 45 degree is nothing but sine 45 upon cos 45. If you divide both are similar terms, if you divide both of them, the answer is 1. Now tan 60 is sine 60 by cos 60. If you divide both of them, 2 get eliminated. Root 3 comes here. And the interesting part is tan 90. So understand, tan 90 is 1 upon 0. 1 upon 0 and 1 upon 0 is not defined. It is not defined. If you see here, if I press 1 divided by 0, it will give you a maths error. Okay, it's a maths error. 1 divided by 0 is not possible. Okay, so that is why tan 90 is basically, in most cases we go and we say tan 90 is infinity. Okay, but in most of the cases, in some books it's written that it's not defined. Okay, so guys, this is a basic for trigonometry which we have covered. Okay, you have to understand this, and in the next lecture I am going to cover about more detail into trigonometry, about height, distance, how to solve word problems and those kind of things. Thank you so much for looking into this video. Please like and subscribe. Thank you.